Cool.
All right, thanks for joining everybody. So super excited to have yet another brown bag this week. We have with us Mo and Hung from Luminous. Luminous is a cool product for operationalizing and scaling data science, as that slide says. So without any further ado, I'm going to pass it off to them to talk about what they do and some of their experience in this area.
Great. Thank you, Aaron. Hi, everyone. Thank you for taking the time to join us today, wherever you may be. My name is Hung Lu. I'm the co-founder of Luminous, as Aaron mentioned, along with my colleague Mo Ansari, who is also on this call.
Oh, great to be here.
First off, Mo and I, we would like to take this opportunity also to thank Aaron to give us this platform to share with the students of Lambda School about our data science experience and how it has informed us to build the Luminous data science platform. We are an early startup, and we're currently in private beta right now, and would love for you all to join the beta program to help us test and provide us feedback to make the platform better. I'm not sure if Sharesh Jyotish is on the call, but I would also like to extend a thank you to him as well for connecting us with Aaron.
I'll go ahead and chime in on that. So Shreyas, I don't know that he's on the call. He's one of our students from an early cohort. And indeed, a lot of these brown bags happen because a student or some random person introduces me to some other cool data science people. So if you're out there and there's some cool service or product or people you know in data science and you're interested in having them for a brown bag, you can DM me and I can possibly arrange it.
Cool. So we've got a lot to cover in a short amount of time. So I do have 4 small slides that I kind of want to go through and just to introduce the platform to you all. How many of you have seen this graphic? So this graphic basically summarizes the data science process into a catchy acronym, OSEMN, or awesome, right? Data science is awesome. For Mo and I, our data science journey began a decade ago at an ed tech company in Phoenix, Arizona. And when we built our first student risk model, we spent most of our days on the first 2 steps, collecting the data for analytics and cleaning it for modeling. And I'm sure as you progress in your data science journey, you will most likely find it to be true that almost 80% of your time in the data science process will be spent in the first 2 steps there. We had to work in coordination with DB admins to pull historical data from their system of record. We didn't know it at the time, but we were doing the things that data engineers are doing today. We were also the developers of the student-facing app that consumed the model APIs to get predictions. And this pattern would continue in other companies and industries. So as you can imagine, we definitely wore multiple hats back then. And of course, to this day, as we work to grow our startup. But early on, we recognized the value in having the right tools for data science so engineers and developers can focus on the core of their company's business, their external product. So that's really the driving motivation for Luminous. Make it easier to gain value faster from data science and make it accessible to anyone. So Luminous doesn't require coding to get started, but we do have, but everything is backed by RESTful APIs, which you can certainly code against. So this graphic, this diagram is kind of our version of the previous awesome diagram. As you can see, so everything kind of flows from the top down. In Luminous, the data science process starts with Terraport, which is our streaming data ingestion and data wrangling product. We designed Terraport with data engineers in mind. We wanted them to have an API to easily collect data for analytics and a user-friendly GUI to design ETL pipelines to wrangle the raw data. They set up this workflow once, and when new data is ingested, Terraport runs the raw data through the pipeline, and the data comes out clean on the other side. You can also add an output sink to your Terraport data pipeline and to write the data to a relational database table, which can then be hooked to a BI tool such as Tableau for more advanced visualizations. The data collected in Terraport can be imported into Learner for use in model training. Learner is our guided machine learning development product. You just tell Learner the target column you want to predict, and Learner does the rest. We put a lot of analysis and insights into Learner to help you interpret the model's results. You don't need to think about, should I try this algorithm or that algorithm? With Learner, it's very easy to build multiple models using many algorithms and compare their results based on different evaluation metrics. If you're somebody who prefers to build your model from scratch, and I absolutely encourage that as part of your Lambda school education, you can consider the models you build with Learner as your baseline models, that your challenger model, the model that you hand code, can target to try and outperform. And we would love to hear, as you're using Learner to build out your baseline models, cases where your hand-coded model beats the Learner models, and we would love to hear that feedback as well. So for some data science platforms, deploying your model into production is the end. For Loominus, ModOps is just the beginning of gaining value from machine learning. You might have heard that your model starts to decay the minute it's put into production. So ModOps offers tooling to track your predictions and automatically retrain your model. So at this point, I will pause if there's any questions that either Mo or I can answer.
Yep. So, well, one is not exactly a question, but Vishnu is saying that he registered for Loominus 12 hours back, got a welcome email, but no invite yet. So I assume that because you're in such an early stage, that's the sort of thing that'll go out soon.
Yes, absolutely. So having access to Loominus is not required for this lecture. What we will definitely open up the registration as soon as possible after this lecture, so that everything that we demonstrate during this lecture, once you're able to register and log in, you can absolutely try with the platform. So
great. And then Molly asks, how different is Loominus Learner from the SageMaker ML pipeline?
That's a great question. Mo, you want to take that one?
Yeah, absolutely. So Loominus takes a more productivity workflow approach, whereas SageMaker is a little bit more low level. So we keep it at a much higher level, and it's definitely more end-to-end integrated all the way down to also collecting the data as predictions are made. Although some of these features are trickling in the AWS and other cloud vendor world. As you'll see, we actually have a workflow UI APIs that kind of bind all of this together in a very opinionated but consistent way, and the opinionated is taken from the kind of industry best practices and kind of packaged together. So at the end of the day, it's a productivity tool which helps you get productive much faster, and also a range of skill sets. Users with different skill sets can get productive. But I think I would say that's the key differentiator.
Great. And hold on, it seemed like there might have been people unmuted. I'm going to do a quick mute all, and then Loominus guests, you can unmute yourselves. All right, go ahead and unmute yourselves to keep presenting. Thank you.
Okay, can you hear me?
Yep.
Great. All right, so let's get to the demo. So our demo, we're going to use some publicly available Internet of Things traffic trace data. And what we're going to do is we're going to build a pipeline a data pipeline to clean and prep the data for modeling. First and foremost, our Terraport API is, we designed it for the use cases of streaming data ingestion, and those use cases involves Internet of Things, traffic, data. It involves e-commerce, clickstream data. So anything that is, high velocity data, that's what really Terraport is geared towards. But obviously, we also provide conveniences for also working with batch data as well, which we'll see in a moment. So once we ingest the data into Terraport and kind of build this pipeline to clean and prep the data for modeling, I'm going to hand over the demo to Mo, and he's going to talk about Learner. And in Learner, we're going to import the data that we just cleaned from Terraport and use that data to train a predictive model. And the first model will basically bootstrap that project with a scikit-learn model, and then we'll examine the results of that model within Learner, and we'll also have opportunities to train additional models and do a side-by-side comparison. And then finally, we'll deploy the best model to ModOps as a REST API and make predictions. So with that said, let's get into the platform. So in Terraport, you first define a data stream. And a data stream essentially is the unit of ingestion within Terraport. So here you go to manage data streams, and here we'll just quickly add a data stream, and we'll just do IoT demo. Just call it demo 2. Now, once you've created your data stream, you have an opportunity to configure that data stream. And we have a couple things that you can attach to the data stream. And the first one being what we call a preprocessor. And just think of this as essentially an adapter for your data stream in the event that your data stream is not CSV or JSON. So your data stream may be a series of like Excel files, it could be PDF files. And at this point, this is when you kind of configure your data stream to tell Terraport that there is some special handling involved. So for this particular exercise, we're not going to attach any preprocessors because essentially the data is already in a CSV format. And then we also have filters that you can apply to your data stream at the point of ingestion. And these filters are built on an extensible framework as well as the preprocessors. So as new use cases come up, they're very easy to add. So for example, we have filters where you can drop rows with missing values, do conversions of date or timestamp fields. And we also have this privacy filter that will allow you to essentially drop or anonymize PII fields in your data stream. And so, for example, let's say you have a column. So I've looked at the data set ahead of time. So for example, let's say, the source location of this particular data set is considered PII. So we have 3 options here. We can anonymize the field to a hash, we can anonymize the field to numeric, or we could drop the field entirely. So if we choose to anonymize the field, that field is basically the column is a new column is added to the data set, and you can definitely use that anonymized field as part of your model training. As part of it becomes the data set as part of the training data set for your models. So once you add your filter, you just kind of confirm that you want to save it. So now that our data stream is essentially configured, and because Terraport is an API, we also provide opportunities for you to test that API by sending it an example JSON payload, or you can also upload, if you have a CSV file that contains a series of essentially data, like rows of data, you can also upload it as a flat file here, and and basically you'll be able to test your data stream as it's being ingested. It'll apply the preprocessors and filters, and the response that you get back will give you a level of confidence that you've properly configured the data stream. So each data stream essentially is associated with a staging table. And so when your data is ingested by Terraport, it first lands in a staging table. And essentially, the staging table contains your ingested data after preprocessors and filters have been applied. And so we, excuse me, Terraport is an API, but we do provide convenience capabilities to work with CSV files, basically tabular data. And so once you get to your staging tables here, which essentially, your staging table is just your data stream, you can actually upload a CSV file, and all you have to do is specify the staging environment. So for example, here we'll do test, and then essentially, let's see if I can find a file here. And you could just drag over a file. And here we've just ingested nearly 34,000 rows, and you can click into, so basically each time when you ingest a data stream, a background task is run to run the data through your preprocessors, if there are any, and also any filters. And so you can click on each one of these tasks, and here we have auditing that will tell you basically the steps that were applied. So here we saw that the privacy filter that we had configured was applied. And then each data stream that is ingested, we have summary stats that you can take a look at to see the data in either column view, or you could also see it in card view as well. And you will see that here, the source location field, we had anonymized it, and basically we attached the anonymized moniker to it, so that you know that this is not the original column, but an anonymized version of that column. And so you can see also the data in its tabular view here as well. So once the data is staged, the next step is, you want to wrangle this data, right? You want to basically transform this data into something that is conducive to modeling. So the first thing you want to do is you create a reporting table. And here we'll do an IoT report. So once you've got your reporting table created, and the name reporting table, basically the idea there is when you set up this data pipeline to essentially transform your raw data into something that is that is more clean and conducive to modeling, but also, keep in mind that that data can also be used for running reports, right? So that's kind of where the name came from for reporting tables. And just like when the data is ingested into a staging table, every time when a reporting table is materialized, meaning that that we apply the data pipeline to the stage data, then there's also a background task that is run to essentially materialize that reporting table. So this here is the designer view for your reporting table. And as you can see, you basically start with a blank canvas. And this designer allows you to just, play with different transforms, play with different inputs. And it's essentially considered that this as your scratch space to essentially build this data pipeline to to munge the data however you want, to basically get it to the point where you feel like it's ready to do modeling. So the very first thing you want to do is you specify the input to your reporting table. And here in this case, we're going to choose the staging table that we previously had ingested. And we're going to specify basically the environment and the source, and then just kind of select the partition for that particular stage data. So within the designer, you're obviously working with a sample of the data. So recall that we had ingested nearly 34,000 rows. Here, as we're designing our data pipeline, we are working with a sample of that, and Terraport randomly sample 5,000 rows for you to work with in the designer. And then so let's quickly take a peek at the data that we're working with here, and just for clarification, once we get to learner, the target column that we're going to specify for training our models, what we're after in this particular exercise is, so this is IoT traffic trace data, and essentially this normality column is going to be our target column, right? We want to essentially predict in the basically the IoT traffic that we're seeing with this data set, which ones are considered normal and which ones are not normal. And so that's so we're going to use the data this data pipeline to essentially munge this particular column into something that is easier to understand insofar as what that particular column represents. So as you can see here, normality has 7 different categories. And what we're going to do is we're going to add a transform to transform this particular column and add a new column, essentially that is a label of essentially just a Boolean, whether the particular data, this particular traffic data, this particular row is considered normal traffic or not normal traffic. So let's get started there. So the first transform we'll add So as you can see, there's many transforms that we've packed into Terraport. Obviously, as new use cases come up or feedback from our beta users are appropriate, then just like our preprocessors and our filters, our transforms are built on an extensible framework that allows for very easy implementation to add additional transforms. So here we'll go ahead and add a SQL select transform, which allows you to write SQL to subset the data. So in this particular case, we are going to do a case select, and I've just going to kind of cheat here and copy and paste. So what this is saying is, for the normality column, we're going to add a new column called label normality that essentially is a Boolean of the normality status of this of the IoT traffic data. So here, once you've configured your transform, you just go ahead and click save here. And then you just essentially click this play button for that particular transform. And the thing to note here is, so everything works top down in the data pipeline. So the previous card feeds into the next card. And at each step, we basically show how this transform changed the data when the operation was applied. And so here, once the operation runs, you can take a look at the summary stats. So here we see that we started with 11 columns, and output we added a 12th column, which is this label normality. So we've munged that particular normality column, which had 7 different categories, essentially into 2 categories. And this will set up our binary classification model that we're going to build in Learner. And the other thing that I'll point out here is that after you run each operation, each transform, you'll have an opportunity to also explore the output. And the cool thing about this particular feature within Terraport is that it allows you to look for some particular insights about the target column that you want to model. So for example, let's see here. So we want to group by the label that we just created. And let's plot that against the source ID. And this basically, my understanding is that this tells you where that IoT traffic originated from. And we're going to look at a bar chart representation of that. So the interesting insight here, as you can see, is that it looks like the majority of the IoT traffic that's coming from the heating control is actually being flagged as not normal. And so there's different charts that you can definitely explore here, but let's do another one here. Let's do a bubble chart. And with a bubble chart, you can add another dimension here. So let's take a look at this anonymized field that we added. So with a numeric column, you can also cut the column so that basically this will help in visualizing the data so that especially when you have a lot of unique values for that particular column, by cutting it, it helps to compact the values, bucket the values so that so that the visualization can come out more clear. So here we'll just cut the numeric column by 10 equal parts. And so here we basically see another view of the label normality being grouped, and we're adding another dimension to the visualization, and also seeing not only how the source ID is impacting our target column, but also this source location also potentially is somehow correlated with that as well. So once you have your data pipeline defined and you're happy with it, the next step is you can, as I mentioned earlier, you can definitely add an output if you like, and this output you can output to a relational database table, and a lot of BI tools out there will take as input a relational database table such as Tableau, and from that you can definitely do more advanced visualizations. So in the interest of time, what I'm going to do is I'm going to show you a reporting table that had previously materialized, and also show you the complete data pipeline there, because we definitely want to also talk about learner and ModOps as well. So this is a data pipeline. Let me go back here. That I had previously set up. And so as you can see here, this was the SQL select transform that we just added previously. But this pipeline also applies some temporal features. Basically here you're creating new features from temporal columns, and it's just we have some basically pre-canned feature types for that are very common to temporal columns. And then and so here we also have a SQL select transform that we use to, because we have this column that contains, as you can imagine, right, raw data in the wild can be messy, may have missing values, and in this particular case, we have a column that had a mix of numeric as well as strings, and so because this column had a majority numeric values, we use this transform to standardize all the values for that column to numeric. And then, so once you have your data pipeline and you're happy with it, we provide a convenience method to essentially materialize that reporting table on the fly. And again, what that means is when you specify the input environment, the input source, and the partition, right? Because in the data pipeline, recall that we are working with a sample of the stage data, whereas here we're actually, when we add data to the reporting table, we're basically we're using all the data from the staging table as our input into our data pipeline. So now here, we had started with nearly 34,000 rows, and now we've munged it down to 14,000 rows. And at this point, it's ready to use as training data for Learner. So at this point, I'm gonna turn the demo over to Mo, and he can talk about Learner, our guided machine learning development product, and then also how to deploy models as REST APIs and make predictions with ModOps. Mo?
You may have to unmute, Mo.
Okay, looks like he's having connection issues. Are you there, Mo?
Yes, I apologize. Been kind of a perfect storm right now. My connection keeps dropping, and the landscaper is also close by making some noise. I apologize for that. Hopefully you can hear me.
Yep, you sound good.
Okay, perfect. Hung, were you ready to hand it off?
Yeah, you came back just in time. So
okay, perfect.
Take it away.
And again, if I drop Hung, feel free to take control of the screen.
Got it.
So I missed some of the last stuff that Hung went over, but I can kind of imagine what he kind of ended on is basically the data preparation part of the pipeline. So now we're getting into taking this data that has been cleansed and prepped and transformed and trying to do some model building from it, specifically predictive modeling for this demo.
You might want to zoom a few percent.
I'm sorry?
Sorry, you might want to zoom in just a few percent.
Got it. Is that better?
Yeah.
Perfect, thank you. So this is Learner. So going back to maybe the home screen, we click into Learner, and what you'll see is a bunch of projects that are of a specific type. So in this case, they're of the predictive model type, and that's kind of what we'll focus on here. So I'm going to kind of do a combination of a few things, show some stuff that's already run, but also kind of give you a flavor of actually how to run it for time's sake. Some of the training can take some time. So to get started, you just have to create a project. And in the simplest form, it just needs a name. I'll call this IoT demo. And your project is pretty much created right away. And you can't do much to it unless you configure it. So all you have to do to configure it is walk through the initial wizard. And once it's configured, you can iteratively build additional models and do additional analysis. So the two main ways to get data directly into Learner today is via Terraport, or you can simply drag over a CSV or Excel, and it'll accept it that way as well. So to keep the demo going from the parts that Hung showed, we'll definitely use Terraport as a source, and we'll go with this IoT data. I believe he was in the test environment, and we will select the source as I believe UI. And we will select the partitions that are available. One thing to say about partitions, for those who are not familiar with storing data at scale, partitions is a way to slice your data into parts. So, big data and systems that can talk to these underlying big data storage tables can take advantage of this partition scheme to quickly get the data that you want rather than doing entire table scans. So once that's there, we're just going to hit the next button here. And we try to make this as a guided process. So this is the part where we mentioned it's kind of like different skill sets can kind of use this without having to have deep knowledge of the overall nuances of data and model building. So as you can see, in this case, based on the data, Learner is able to make some recommendations about potentially changing the types of your data, or in some cases even dropping. So in this case, it is basically
Hung, are you there?
Yes, I'm here.
Did Mo freeze for you as well?
He did. Mo, you there? Looks like it froze on Mo. So let me, is there a way for me to share, even though he hasn't stopped sharing?
Let's see if I can All right, I can take over the screen for a brief moment. So I will do that. And then I can relinquish it. All right. There's a blank Firefox window. And now it's all yours.
Okay, so I will.
Or
oh
maybe
wait,
not.
no, you cannot start.
It went back to him.
Oops. Sorry, guys.
Yeah, that's okay. I mean, I'll see if there's a way that I can bump. Oh, yeah, I can. I found it. All right. You should be able to share in a moment.
Okay.
At least I clicked stop participants sharing. All right, well, thank you for your patience, audience, folks.
Yes, thank you everyone for your patience.
While you wait, video conferencing is always hard. I've been using it for a while, but it's always got bumps. It is miraculous when you think the number of bytes were just shuffling back and forth in almost real time across the continent.
Yeah, and like Mo said, he's I think they're building some new tower near where he's at, and maybe that's having conflicts with his current internet provider.
All right, looks like we got his screen relinquished.
Can you guys hear me?
Oh, you're back.
He's back.
Yes, we can hear you.
So I am on a low bandwidth tether. So let's see if this works. I apologize. Completely perfect storm happening right now. So let me just get right back to the screen. And Hung, I'll rely on you to text me if the quality drops in any way.
Okay.
Cool, thank you, appreciate it. So we were at the screen. I'll kind of try to move around faster due to sake of time. So as you can see, we can change the data types here, and we'll assume that we'll just maybe take his recommendations, and we will go on to the next screen. And due to bandwidth, this might just be slightly slower than it should be. But as it's kind of spinning, I will tell you kind of what happens in the next screen. Oh, there we go. So in this case, we're going to use the label normality column that Hung prepped. It defaults to the lesser of the case. It recognizes that this is a binary problem, and it gives you some data statistics right away, so you can kind of make sure you know what you're dealing with in terms of what you're trying to predict here. And again, all of this can be done iteratively after the project is initialized as well. And as you can see, the not normal case happens less than 1%, so it's a needle in a haystack problem. Typically, in machine learning, we're typically finding the harder thing to predict. If something is happening 90% of the time, chances are you don't need a very sophisticated model to predict that. So in this case, it's a needle in a haystack problem, so we are going to try to rely on some machine learning type models here. You can also exclude features from the model as well. Although source ID isn't a true ID, I'm going to treat it like an ID and say, hey, maybe we don't need to actually include that in the training process. We also have the ability to group the test train split. Sometimes you want to make sure that a certain user or a certain entity with a certain ID only lands in one bucket and is not cross-pollinated or cross-contaminated between test and train. So you can essentially specify that here. Since we don't have that problem with this data, I'm simply going to go with the default test train split and go to the next screen. This is where it gets interesting. We've built the learner part as what we called our provider architecture framework. What we can do is take proven machine learning libraries and plug them into our platform as a provider. So we have currently wired up 4 providers: scikit-learn, XGBoost, LightGBM, and TensorFlow. We have a few more in the process right now. But essentially what it does is it gives you a form view on top of what you would hand code anyway. So it does give you the lower level dials and controls to go ahead and select your algorithm as well as the parameters and run it. Although it's not available in the public version that we're using right now, we have ability to automatically find the best models and amongst a provider, or find the best model amongst all providers, and that obviously takes a lot of compute power. So again, for sake of time, I'm just going to kind of back up a little bit and maybe just dive into one that we kind of pre-trained ahead of time. So this is essentially the same data. The first thing you'll see is you land into the home screen here for the project. On the left-hand side, we have features that operate at an analysis level, at the project level. And on the right-hand side, we have what we call the model stream. And the model stream is sorted by the best model based on the metric you choose. So since this is a needle in a haystack problem, a better metric than accuracy might be something called the F1 score. So we can sort it and see what is giving the best F1 score. And if we had multiple labels, in this case we're only predicting one, it would actually display amongst all the labels what the best model is right away, so you can drill into it right away. So once your model is trained, you probably want to look inside of it. And this is the screen that lets you kind of go inside of your model. And again, apologize for the bandwidth here. I think that is definitely affecting some of this stuff here. Give it a shot one more time. So while that loads, I'll mention a few other things. After you've done training, let's say you want to train additional models as well, what you can basically do is click this button, and you can basically go through that same form again and iteratively go through that same process again one more time. So that's how we can kind of keep training while we're learning from previous runs, and keep doing it in a very scientific way, in that for every run we stamp the training data, the test data, and the model. So if you are using multiple data science tools like a Jupyter Notebook, you maybe want to bring this model, you can download it as a standard pipeline model, and you can bring it into your Python environment and start to integrate it in a more low-level way as well. Having said that, this model that has loaded, you'll see it gives you all the metadata about the model. It also gives you the parameters used. If it was done via a grid search or something similar, it would give you the best parameters that were learned as well. For each one of the model, very standard practice, we evaluate it against the train set, the test set, and the cross-validation set. And along with that, we give you the charts that go with that, kind of the standard chart. So if this was a regression problem, this screen would look different. If it was a multi-class problem, it would look different. In this case, it's a binary classification problem, so it's rendering things that are relevant for that. So it doesn't, you don't have to takes the guesswork out and kind of displays what is kind of the standard way of looking at this stuff. As you saw on the Terraport side, we also have some auditing here in a similar, consistent way. You probably want to get into a featurizer. So here is where it gets interesting. We have an auto featurizer under the hood. It automatically featurizes and finds the best featurization scheme. And based on that, it builds the models. In this case, because there were a lot of categorical values, it basically turned them into these one-hot encoded or dummy-like values. And it lets you basically explore it across not only the training set, but also the test set. And also lets you kind of compare. The comparison is actually important because sometimes you get strange results that are not intuitive. And one side effect of that happening is that the train and the test split, the data statistics or distributions are not the same. So it gives you a very low-level view into it. So generally speaking, these two distributions should look very similar for a good split. We also have something called a feature matrix. I'm gonna run this on my tethering connection. Let's see if it connects. But essentially what this does is it lets you look at features across features versus features, and it's kind of a common way that people explore these charts and see feature interactions or relationships. So it kind of gives you that here in a single place. You can always add more features that you want to consider, but essentially you're looking for some interesting patterns amongst the features that are interacting with each other. The algorithm part is very specific to the algorithm that was run. In this case, it was a random forest, so feature importance is kind of bubbled up and given to you in a visual way, so you can kind of see what went inside of that model as well. Diagnostics is another part where we can go a little bit deeper into it to understand where your model is suffering and where it's performing. We give you things like calibration charts. We also let you browse the bin confidence to see what the hotspots of your model are. So is it overconfident in a certain area, or if it's underconfident in another area? What essentially you can end up doing is you can actually drill into the bins and actually start to see some of the data that went into it. And hopefully that gives you some insights into what actually is causing the model to go one way or the other. So typically overconfident or underconfident, this is the place to kind of explore that a little bit as well. And kind of in line with what we're ultimately trying to show here is interactive way to also interact with your model. So this isn't exactly our model API, But currently we have a kind of exposed a way to do this at a somewhat low level, and we're building visualizations on top of it currently. But essentially what it's doing is it's generated a payload, not with your featureized data, but from your raw data, just randomly based on the properties of your data. And you can essentially do a predict and just to see what will happen for these values that are there. So in other words, you can hand munge these values and run it again, and you can see the effect that it'll have on your model and its predictions. At a very high level, in this case, because it is a classifier, it is giving you the predicted probabilities, the predicted class, the input, and all of that stuff. So you have all of that available to kind of inspect as you're doing this. In the very near future, we are working on higher level visualizations on top of this, currently actively being developed. So we will make this a little bit more analyst friendly as well. A few other features related to model diagnostic. You want to basically see the actuals versus the predicted. Gives you all of that, both in test and train, and for similar reasons as we say why you want to compare it, gives you a comparative view as well between the two data sets to see if things are kind of aligning as you expect. So I see we're getting very close to time here, so I'm just quickly going to maybe show you how to deploy this as a one-click model deployment. Hopefully the bandwidth is friendly with me here. So once you kind of find the best model, typically maybe it's the best one with the F1 score or the best accuracy or something in between, you want to essentially deploy that model. So what you can essentially do is push a button and you go into our ModOps deployment screen here. And what ModOps deployment screen is doing is basically giving a chance to validate once that this is the model that you're actually interested in deploying. But what I do want to call out is on the left-hand side, any of the providers that we provide under the hood, you can actually upload those pre-built models as long as they follow kind of a standard way of building the models, and you can literally drag them over, and you can also turn those into APIs. In this case, I'll focus on the learner model, and what we'll do is we'll go ahead and deploy that model. We'll go ahead and deploy that model. And what it's actually doing, it's kind of putting it on the ModOps side of things, and it is exposing this as an API, and it's also giving you controls to that API, and essentially we're in the ModOps screen right now. So this model has been deployed. With a push button, we can enable, disable it, give you the same way to download the training test data. If this was modeled from the wild and you had dragged it over, the system will actually ask you to provide the training test data. Certainly ask you to explore that when you start to explore the platform. But at a very high level, this model is deployed. It automatically will create the tracking dashboards for you. In this case, no predictions made yet. And it'll also give you the true API for calling this in a production-like setting. So the three APIs that ModOps gives you right off the bat is a get model, make predictions, and inform predictions. The get model will simply give you the metadata about the model. Again, it will give it to you in a consistent way. You can think of this as a model repository if you were to bring your own models. But in this case, it is a learner model, so you get basically the model record back. You can actually make predictions. So let's generate what a production payload may look like if an external application were to call this model and try to get a prediction. It's a little bit different than the payload we saw on the learner side, in that it is designed and optimized for low latency, high throughput calls. And what we'll do is just make a quick post. And when this is posting, it's actually loading up the model for the first time. It'll cache it for subsequent runs. So on average, the calls are sub-second. And what it's essentially done is giving you a view of what this looks like in a production call. So in this case, gives you the probabilities, the label. It also gives you a request ID. The request ID is something that the client or the caller can store. And in the future, when the outcomes are known, they can actually provide that as the input to what the actual outcome was. And these are the signals that ModOps uses to, number one, track your model in production and compare it between test, train, and cross-validation from lab, but also eventually collects this data up and allows you to do automatic training when enough data builds up as well, and to keep your models fresh and whatnot. So I do want to be respectful of the time. We just hit the mark, I think, right on the dot. I definitely, Hung and I can stick around a little bit if there are questions as well.
Yeah, very cool. Sorry, go ahead, Hung.
Yeah, Mo, if you can quickly show our audience the feedback widget so that when they have a chance to use the platform, they can definitely provide us feedback directly from the platform itself.
Yeah, good one. So just on the right-hand menu on the top, there is a feedback, and we do ask you if you can please classify the kind of feedback you're giving us. That'll make it really easy for us to trace it and give a description of what's actually happening. And this goes right into our project management system, and we get alert right away, and we're definitely very eager to hear from you.
Great, very cool platform, and I like in particular the ModOps section. I can already see, oh, you can put scikit-learn or TensorFlow stuff there. So hint, hint, students who are working on projects and you might want to do a simple productionization of your model, this might be a cool tool to check out. But it's a little bit late for questions, so I think I'll just suggest that students use that feedback form like you suggested, if that works for everybody. But thank you so much for coming by and talking about your product and for offering this to our students. Yeah.
Likewise. Thank you very much, and bearing with the technical difficulties. Thank you so much.
Video conferencing is, you know, it's one of the hard problems of tech, but that's okay. All right. Thanks everybody, and make sure to take some time away from screen before you dig into whatever your afternoon assignment is, and definitely check out Luminous.
Thank you very much. Thank you,
Thank you, guys.